Hi, I'm Michael Cohn from Advanced Tubular Technologies. I'm the developer of VTube-LASER software that runs with the ferro arm in order to scan tubings in and correct tube bending machines. What I'd like to discuss today is the concept of scanning techniques that really work on tubing. The fact is, every tube has some ovality and some have a lot of deformation. Even precise tubes like this one. This is an aerospace tube with a fabrication process that renders a very precise diameter. Even it has some ovality. And ovality itself is something that we must overcome when we measure a tube in order to get repeatable and accurate measurements of the tube's center line itself. What we're going to do is we're going to start by measuring just a straight here. And I'm going to use the traditional method of scanning this straight by just scanning one side of the straight, and then we're going to observe the result as it calculates the diameter of the straight measured on one side. We'll go to Measure Process, Outer Diameter, Measure, and Scan. The diameter calculated on this side is going to be 2.9495. It's going to be lower. And we know that this is a 3-inch nominal tube. So the question becomes, well, is this tube really 2.941 inches in diameter? Well, let's scan down the other side and see what VTube finds. This side is reporting something slightly larger, 3.004 inches. So then we say, okay, then this side must represent the diameter more accurately. Well, it's true, it does. However, what we're looking for is the center line of the tube in its actual shape in the real world. So what we're going to do is switch to another scanning technique called the wide diameter scan technique, which we've been using and teaching lately that I think really solves this problem. So the goal is to get as much of the diameter as possible, which we can do with a 7-axis arm, because with a 7-axis arm you can actually move around the tube like this. So we're going to scan up one side, and we're going to let the green button up, and we're going to scan down the other side like this. And then we're going to allow it to calculate the diameter. We're going to find the diameter is different yet. Now I trust that reading, that diameter, more than I trust the previous two, because that's going to be the average of taking surface points from this side and surface points from this side. So it's reading 3.024 here. It's reading even larger, but I still think this is probably more precise. What we're going to do is we're going to go down this side again, and I'm going to scan roughly this side. I'm not going to go all the way to the other side. And we're going to try that measurement again and see what happens with the calculated diameter, 3.017. So that we see what happens is when we take a wide diameter scan is we get a more true representation of what's really happening in the straight. It takes into account the ovality and deformation, even in a part that's very precise like this one. So it's important to use as much as possible the wide diameter scan. Some customers like to scan up one side here and then just shift slightly and then scan back this way. That's okay, but if you can scan one side and then really shift more to capture the other side of the diameter, that's even better. We've also found that on very large diameter tubes like 12-inch diameter, a 12-inch diameter tube requires that you do a wide diameter scan. If you attempt to measure up one side of a 12-inch tube and don't take the other side scanning back, then VTube-LASER will probably fail in cylinder fit every time. So it becomes more critical as the diameter of the tube increases. That's the end of our demonstration. If you have any questions, please of course feel free to email me at michael.cohn@advancedtubular.com. Thanks for watching. Bye.